The Shiina esterification and the Yamaguchi cyclization reactions are two reactions that have a mixed anhydrous intermediate in common, as well as forming an ester product. A major difference between the two is that the Yamaguchi cyclization forms a cyclic ester, whereas the Shiina esterification forms an alkyl ester. So both reactions can start with a simple alkyl carboxylic acid. In the Shiina reaction, the carboxylic acid is deprotonated, as well as the aromatic anhydride being protonated, forming these structures here. Then the negatively charged oxygen will then attack the carbonyl, forming an alcohol structure here. And then the alcohol is then deprotonated, and the anhydrous oxygen is then protonated from the Lewis acid. And then from here, the carbonyl is then reformed, kicking off benzoic acid. Then the alcohol then attacks the ester farthest from the aromatic, breaking off its ester bond, forming a carboxylic acid with the aromatic ring and reforming a new ester with the alcohol. The Yamaguchi reaction starts off very similarly, where triethylamine attacks the carboxylic acid, deprotonating it, and then the oxygen from the carboxylic acid will then attack the carbonyl from TCBC, which is otherwise known as Yamaguchi's reagent. Let me structure here. The carbonyl is then reformed, kicking off the chlorine leaving group. And then DMAP will then attack the carbonyl farthest from the aromatic. And then the carbonyl will then reform, kicking off the aromatic leaving group. The alcohol will then come around and attack the carbonyl, which will then reform, kicking off DMAP, forming a cyclic structure. The two then near product structures are then protonated and deprotonated to negate any charge, forming these products here.